Hello and welcome to another Developer Essentials. So this time around, we're taking a look at a topic called inheritance. And inheritance is a really important aspect. It's something that it's a feature of the C# language. Many other languages, you'll find that as a feature as well in them. And it's something that in particular, as we start to scale up our games, as we have larger and more complex games, inheritance provides a way for us to write not only less code, but simpler code. So it's a really key aspect with it that inheritance allows us to be simplifying what we're writing. And it can be a bit of a weird concept to understand. And that's what we're going to be doing is trying to dive into that, get a bit of a better understanding of what does it actually mean. And so how I'm going to go about doing this is initially I'm going to set up a scene that has our usual plane, and I'm going to, as always, I'll set up some colors and with materials for that. So let's set up a folder for our materials, because what I'm going to do is I'm going to have several different things. So there'll be several different objects, and I want them to all do a slightly different thing, but I want them to do that different thing in response to the same stimulus, and to allow some easy ways of working with that. And we'll see what I mean, because the idea is here, if you had animals in your game, for example, and you wanted to be able to tell an animal to make its default sound. So, a dog, you would expect a bark, but different breeds of dog, you would expect different types of barks. If you was a cat, you'd expect a meow there. So different animals are going to make different sounds, but they're all getting the same command to vocalize. So that's something where we don't want to have it that we have to go, okay, are you a cat? Okay, play a meow. Are you a dog? Okay, play a bark. If you're this, do this particular thing. We don't want to have to write different versions of that code for everything. We just want to have one easy version where we can just say, no, do this. And it can choose how it does it. And that's the key thing. The object itself that we're talking to is choosing how it interprets that command. And so we're going to set up a bunch of different things here. We're going to have our ground. And then material-wise, I'm just going to have a few different ones. Red, green, and a blue. So rather than having animals, because I don't think it would be helpful me trying to make different animals, because a 3D modeler or artist I am definitely not. And as amusing as it might be to see my attempt at drawing a dog and cat and so forth, I don't think it would be helpful. So cube, which is going to be red. So we give it that material, and we'll configure the materials in a moment. So we've got our cube. We're also going to have a sphere. The sphere is going to be green. And then we're going to chuck in a capsule, which is going to be blue. So just run a few different things here, just because we want them to be doing, easily stand out, and we want them to be doing slightly different things. So let's make our ground a nice sort of dark gray, so things will stand out against it. And then our materials here, can just get these set up. So we've got our blue, our green, and then finally our red. And we'll just space these out a little bit so that they are all easily spotted. -3 and 3. So, okay, we're going to set this up and have this be doing a particular bit of logic for this. So we're going to get everything positioned so it's touching the ground. a little bit. There we go. We've got all of our different objects set up. So let's have a look at what we want to be able to be doing here. So we want to have our scripts, and we are going to set up a script, and this is going to be, let's assume these are different characters in our world. So we're going to start this off and we're going to call this character base. Very intentionally, I'm using base as part of this name here. So we want character base. And what I want to be able to do is I want to be able to have a public void, and this is going to be perform intro. So perform intro, and it will do some particular action. And I want to have a overall controlling object. So I might have something where, let's set up just a really basic UI with a simple button. Perform intros. And we're going to create another one that's our character manager. So we'll have a script character manager, and its job is it's going to be telling all of our characters to perform their intro. So what it will do is I'm not going to manually set in the inspector the characters. I'm going to have list of character base, all characters, and then what I'm going to do is in start, I'm going to locate those. So all characters is a new list of character base, and then what I'm going to do is find objects of type character base. So we're just retrieving all of the characters. So find all character base instances in the scene that are active. And that's an important thing, that it only is going to find ones that are active. If the game object is inactive, then it won't actually be able to find it at that point in time. Then we will have public void perform intros. So what I'll be able to do is for each character in all characters, character dot perform intro. Tell all characters to perform their intro. So this character manager script here, I will not need to modify that any further. That's one of the key advantages that we'll get with inheritance is at the moment we don't have inheritance happening. We will be bringing inheritance in momentarily, but the key thing is when we do, none of this will change. I will not need to edit this script. And I'm going to close it because I very specifically won't need to touch it. I will link up my perform intros button just so that that is able to be doing its thing. Perform intros. And I want to make this a little bit larger as well. So we'll scale with screen size, and then let's anchor this down the bottom. Just so we've got that nicely positioned. 10 and 10. That looks pretty good. So that will talk to our character manager to tell it to perform those intros. And then we'll see what we actually can do in terms of with the inheritance. Because I haven't added those character scripts onto these, but we will actually do that in a moment. Because what I'm going to do is now I'm going to set up character cube. Then I'm going to set up character for the sphere. and then a character for the capsule. So these scripts will handle the actual key parts of the logic. So let's link these scripts up. Character sphere and character cube needs to be linked up as well. So we've got cube, sphere, capsule all linked up. So let's look at editing these scripts, because at the moment I don't actually have any inheritance happening. Well, I don't have, be more accurate to say, I don't have any inheritance that I've customized. This, which we've seen this a whole bunch of times, what this is actually saying is character capsule inherits from mono behavior. So when we inherit from something, we gain access to the functions, the methods within it, and also the variables within it. So in our normal classes that we set up here, we're used to being able to access transform, for example, to control the position. I can access that because mono behavior provides that. We can actually see, if we scroll through, can see a lot of things. So when we looked at coroutines, starting of a coroutine is something that is provided to us by mono behavior. It gives the mechanism for doing that. So the reason we were able to do that was because this was providing it. So we can only see the functions typically with the stuff. Sometimes, depending upon whether it's actually giving us the full code or not, we might not be able to see the particular ones. We can step through and see, well, mono behavior inherits from behavior. Behavior inherits from component. Component, and this is where we can see our transform. So transform is actually something that's provided quite a few levels above. So inheritance can go across multiple levels. So our character base class, its parent is mono behavior. Its grandparent is behavior, and its great-grandparent is component. And it gets everything from all of those layers above it, has access to those functions, to those variables from the layers above it. And that means by setting up our own one, we can create a function that then the children can use and can access. So it allows us to share resources and things like that, to share functions, to share variables. So we don't need to be duplicating stuff as much. It's a powerful method. So we can change our characters here to make them inherit. We change this from mono behavior to character base. We do that with all of these. Character base and character base again. So that's good. We've got that set up. So we want each class to substitute in its own version of perform intro. So for the cube, for example, public void perform intro. Now, if you've seen bits of stuff with inheritance before, you might know why I'm seeing this error message, well, not error, this warning indicator. And it's saying that it hides the inherited member. So when we are working with inheritance, we can repeat a function. The function name can be duplicated in one of the child classes. But we need to tell it how to interpret that. And we can tell it that we are entirely replacing that parent class function. Or we have the other option of we can override it if we're wanting to support overriding. And so in this case, the way we do that is we put in virtual. Virtual says it's going to do a little bit of extra logic when we tell it to run this function. And in particular, what it's going to do is it is going to work out when it sees in our character manager, okay, you've got a list of character bases. You're telling this character base to perform intro. But because that function is virtual, it says, okay, you've told me to perform intro on this thing. It's there in this list of character base, but what is it really? Is it really a character base, or is it a sphere or a cube or a capsule? And then it will find in a sphere, cube, or capsule a version of perform intro that is overriding it. So this says override the version in the parent. If we wanted to call the parent one, we actually can. We could say base perform intro. This runs the version of this from the base class. In this case, we don't want to do that. We just want to perform our own sort of intro logic, and that's okay. So I'm going to have a bool intro underway. Well, this is something that multiple of our classes would use this. So each of them is going to keep track of that intro that it's happening. That would be a useful thing to have in the base class. This is how we decide what stuff goes in the base class. We look and see, well, if it's common, let's put it in the base class. So that's cool. I can do that. And then that means in the intro here, I can just say intro under, except now I can't access it. And so when we're working with inheritance, we've seen sort of public and we've seen not listing something. So these are called access levels. And we have three main access levels that we will encounter: public, private, and protected. Public, we've seen, makes things accessible, not just within the class, but outside of it. If something is not listed, the default is private. So the default access level is private. With private, it can't be accessed outside of the class, and it can't be accessed by children. Now, we could make this public to have it be accessible by the child class, but we don't necessarily want this to be able to be seen by anything outside of the character. So we have the option of protected. Protected means that it can't be seen outside of this class and this class's children. So only things that inherit off of character base are going to be able to see this variable. That now means that we can, in perform intro, say intro underway, true. We want to track our progress of the intro. So again, that would probably be a common thing. So intro progress is equal to 0. Intro progress, we just reset it. So then in update, we can check, well, if intro is underway, and actually, yeah, we just need to check if intro is underway. Then we can say intro progress. Well, our intro is going to take a length of time, isn't it? And again, that's probably common between all of these. So protected, float, intro time. And that's probably something that we want to have accessible. So serialize field, float, intro time, and maybe the intro takes 2 seconds. But again, we need to access that in other classes. So again, we can do serialize field of something that is protected. So serialized field can be used on protected ones and also ones where we don't specify, so where they're private. That means our intro progress, we can update that based upon time.delta time divided by intro. We can check if intro progress is greater than or equal to 1. And if it is, intro underway is off. So intro complete, intro in progress. But this is something where actually when we're looking at this is going to be common. All of them are going to do the same thing for the performing of the intro. So actually, this can just go into our perform intro here. And this is where it would make sense for us to run the base one. There might be additional setup stuff that a particular class needs to do. But our update, that's the same. This is largely going to be common logic. In here, we would do something that is class specific, but otherwise, the rest of it is generic. So we can bring that over here. Now, our update, we can make that protected virtual. And we see as soon as I do that, these ones want to change. So protected override, and I call the parent, so base update, and this is going to be the same for all of these. But what this means is I am actually going to get rid of perform intro here for the cube because I don't really need it. What it's doing is going to be common. And this is a thing. When we're working with inheritance, you don't need to necessarily get it perfect first time, but just identify those opportunities where you can start to make changes and refactor it, and refactor them as you're going. Because what I would say down here then is, okay, update, intro. Now this update intro will change based upon the particular character. So this would be a protected virtual update intro, and that would be void. And then this I'll be able to set up in here as a protected override one for each of these. And what's handy is each of these ones can do very different things, but they've already, a lot of the work has already been done for them. They already have this progress value that's going from 0 to 1 calculated. It's already tracking and deciding whether or not it should actually run the intro update. So a lot of the work is already being taken care of for us. So it simplifies our processes here a lot. Because it means then our sphere, so okay, the sphere, the process might be for it to bounce. So with this, I might have my bounce height. Maybe it goes up 2 meters, and I might have an animation curve for that. Oops, animation curve, bounce curve. I'm going to need my initial position, but that's something where I reckon a lot of the things are going to need that. So I would store my initial position. So I'm able to avoid needing to have a lot of logic in each of these child classes, because our update intro here would end up being, well, our transform position. That's going to be our initial position, plus we can say our vector3.up multiplied by our bounce curve. We can just access our intro progress, and we put in our bounce height. So very little logic ending up needing for it. Our update, well, if we're not doing anything extra in it, we could potentially get rid of that, because we're likely not. So that's one where I could get rid of that. I'm going to leave it for now, just because it's handy to show this process of calling that base version. Perform intro, I'm not overriding it in the children, which means this version will run. And that's the thing, we don't have to override everything. We can, but we don't have to. So that works for sphere. Cube, I think for the cube, a rotation would be a good option there. So what we could be doing for that is transform Euler angles, and this could be where what we are doing is a new vector 3, 0, and, well, 360 degrees is a full rotation. So intro progress. And we could do this that we actually potentially rotate in all axes, but I think just rotating in one of the axes is fine. So that works. Our capsule, let's make it that our capsule messes with the scale. And again, this is something where what I could do is protected, vector 3, initial scale. Now I could, other things might end up needing to use that, but maybe in this case where I don't have a direct need for it, I'll just have it here. And then well, initial scale is equal to transform local scale. And then what I would be able to do is my transform local scale. And again, this is where I think a animation curve would come in handy to be able to set this up. Scale curve. So my local scale is going to be my initial one multiplied by 1 plus the scale curve evaluated for my intro progress. So I can just have it expand up in size and then decrease. So 3 very different ways of it behaving, but I've not had to write as much code because they were able to reuse a lot of this stuff. So this is, 10 lines of code here, another couple of lines here and here. It's about sort of 15 lines of code that I'm saving from each one, and that's just from a simple case. If I was doing this with each of these not inheriting off of character base, that would be 15 extra lines in here. It's a lot. It's rapidly adds up for saving time. So let's configure my animation curves because I want to make sure I've got those nicely set up. Because what these are going to do is I want a midpoint 1, but that midpoint is 1, 0.5, and then my endpoint is at a value of 0. We can just adjust the shape. That's good. And I can copy that because I'll use the exact same thing for the bounce one. So, still haven't opened up the character manager or changed it, even though these are all set up for inheritance. So let's see what happens. So they run their logic. Means that I didn't need to add in anything extra for our character manager. So when you're doing a find, you can put the base type of a class here, and this will find not just things that are a character base, but things that are children of character base. So really, really handy for being able to track things down. Makes it really great. Like I've set it like this, you can have your base classes and you just are able to reuse that logic. So we've just stored this in here in a list. When we're running this with perform intro, so what happens at this point is character runs perform intro. It comes over to here and says, okay, well, this is virtual. Well, let's check, because I know that I'm running on a sphere and a cube and a capsule. Are these customizing that? Are they doing any changes? And they're not. So, okay, I'll just run perform intro. And then perform intro kicks off things being able to update. Now, when external to our classes, so when Unity Engine itself is coming along and saying, hey, you need to update, because every frame Unity tells any active game object to update. Again, it sees, well, this thing's virtual. Are its children customizing it? And they are. So it goes and runs the child version, which says, hey, just run the base version, run the version that you've already got, and it will do that. And it runs this update intro, which again does that same logic of checking, okay, what is the actual type of thing I'm referring to here? Okay, that's the type of it. So let's check for the customization and then can run it. So anytime where you have related things in your level, in your game, so areas where I would always be thinking about using inheritance would be stuff where, if you have multiple characters, then do those characters do have a similar verb, but the way they execute that verb is different. So that's a good framing of how to be thinking about this. Do they have a different way of reacting, of interpreting that verb? If they do, then inheritance can be a good option. If they don't, then you may not want to use inheritance for that. So examples there for, a character being told to talk. Well, that's going to be a similar thing for all of them. So you wouldn't really need a different class there for each character that can talk. If you've got different ways of moving though, so if you've got one character that can fly, one character that can walk, one character that can swim, those are different ways of executing that same verb of moving. Same as in this case, perform intro was our verb, but they each interpret it differently. They each do that verb in a different way. So that's a good way, I think, for getting a sense of, is inheritance potentially an option? Is the interpretation, the execution of a verb, different between your things? If it is, then inheritance can be a good option there, and it'll let you eliminate duplicate code. And that's the other thing that can clue you in that inheritance might be an option to be looking at, is if you find that you're duplicating a lot of code and doing same code with similar things in a similar category, then that's something where using inheritance could be an option there for removing some of that redundancy. And that is the goal. The goal with inheritance is about removing redundancy and avoiding duplication of code and simplifying our setup there. Because less code is always better. The less code you have, the less of a surface area for bugs, which means the less potential problems where things could go wrong. So we've seen this sort of side of it. What if we need to actually tell what something is? What if the character manager needs to specifically know, is this character a sphere, or is it a cube? Is it a capsule? Well, we can do that because maybe there's a function that is only on sphere. Maybe there is a function here, do sphere things. Sphere things. So we want to only run this on ones that are able to do sphere things. So let's extend this. And I want to set up so I can test if a character is a particular type. So I can say, well, f character is character underscore sphere, then character as character sphere dot do sphere things. Because before that, I would not be able to do sphere things is not there. So this is one method of doing that. The other method, which is more akin to the C++ way of doing it, is I can say f character underscore sphere character is not equal to null, then character sphere character dot do sphere things. So this first one is more of the C# way of doing it, using is and as. This is more the C++ way, where we are doing a cast. So where you see a variable type inside parentheses, that is doing a cast. And one of the things with inheritance is if you cast something to a type that it isn't. So casting a cube to a sphere, that will become null. So that casting method can be used for doing that process, for being able to check the type of something. And we'll be able to see when we perform intros, and we'll actually get an error on that. So that, if we wanted to use this approach, we would actually need to typically wrap that in a try catch, things like of that for catching the exception. So this will actually cause errors, which is handy. So we can turn that off. And we'll run this again because we want to make sure that we're getting our output. Run this, perform intros, we got our sphere things message. So we can interrogate a particular object and check the type of it. But this is an important thing. Casting, putting type in parentheses for a variable, will fail if the type does not match. Will fail and cause an exception. So that's just an important thing to be aware of. That this is not generally the recommended way in C#. You can use more like of this in C++. This will cause an exception, so you need to be very cautious with where you use this. But we can use the C# method. So check if this is a sphere. So in the rare cases where in something where we need to, we've got our generic list of the types of things and we need to actually work out, no, what specifically is this? And in particular, are you a particular thing? So are you, in this case, a sphere? And then work with it as that, because there might be some functions or a variable that is very specific to that. Then we can do that conversion using is and as. So it can be really, really handy there with that. Now, in terms of with this, I could then easily add in further sort of child classes from this if I needed. Things like this where I don't need the start. I'm going to get rid of those. I'll leave it for a character capsule though. And we can close this one. Now, we put virtual and override for a bunch of these other ones. We haven't done that for character capsule. So the question is then with it, what's actually happening? Is this start and this start both running? Let's find out. So debug log capsule start, or I'm going to put the game object name so that we can easily tell what it's running for. And this is the thing, like with code, don't be afraid to just experiment. Check in debug logs for seeing what's actually happening. It's a great way if you're not sure of, okay, well, which one of these is running? Put in some debug logs, because we've put those in, and now this, when we run it, it will tell us which stuff is running. So we run it, and we can see we get start for cube, start for sphere, capsule start. So this hasn't run, which means the character capsule one hasn't actually set the initial position. So that's something where we need to be cautious of, where we haven't gone and marked it as virtual. Then we can't guarantee, what happens is going to vary a little bit. In this case, because Unity is directly knowing, yep, this is a capsule. When Unity tells it to start, it will call the version here. However, if we were doing that via our character manager, where it has it as the character base, we might not see the same behavior. So let's test that. First, I'm going to fix this, and we'll put in a specific test case of that to see what happens. Override base start. So we're going to set up here a demo function that we're going to make public, void demo function, debug log base demo called on game object name. So that's good. And then in the capsule, have the same thing, base demo called on, so this won't be capsule demo function, base demo function. And then in our character manager here, we are just going to say character dot demo function. Now it's already giving us a warning. We don't see that when we had our start function. So with the start one, it won't give you that warning, but we will encounter it with our capsule like of this. So let's see what behavior we get in this case when we run this. Because we've set up a function where we have our base version and we've substituted in another version in the capsule. Let's run that. So we see base demo for cube, base demo for sphere, base demo for capsule. So because we haven't actually told it about overriding it, it's going to just run the base one. Because character manager just sees, well, it's told me to run demo function. Demo function here doesn't say that you're overriding it, so I'm going to not. Now, it does mention here of like, well, I can use new if I'm intending to hide it. Let's see what that does. Does that fix the issue? Because it's told us, that's what the error message has told us, that this will resolve the problem, but will it? Let's find out. Again, experimentation is a good approach for this. So we can see base demo, still base demo. So new fixes the error, but it doesn't fix the problem. We have to, if we want the behavior where our capsule can change the input or change substitute its own version of that function. When we are working with a list of that class, we have to use virtual and override. So new, despite the error message saying that was a solution, you can see now it runs capsule demo function. So whenever we want our functions to be able to be overridden, and in particular, when they are something where we're storing a list of these character base class, so our base class. So inheritance has a number of components to it. So we've seen, we've got this idea of sharing variables, sharing functions, and we've seen that things like our character manager, if it runs those functions, then we can customize the behavior of them, and that it can do this extra logic where it checks and sees, okay, well, which version of this function should I run? So that process of working out what version of the function it should run, this is something that you might see referred to as a virtual function dispatch. So that process only happens when we have things that are virtual and then they're overridden. If they're not, it won't do that logic. And we saw that with our demo function. Until we set that demo function to be using virtual and override, it would not call the customized version. So really important thing to be aware of when you're working with inheritance. You must be using things like virtual and override if you want that virtual dispatch to be happening where it's actually looking at the type of thing. So just to recap on a bunch of the bits for this. How to decide whether you should be using inheritance. A good test there is, for the same verb, do you need very different logic to happen? Not using different data, like a different sound file or a different animation, but very different code, different logic that's happening there. If you are, then inheritance is a potential advantage there. When you're setting up your functions, you want to keep in mind that unless a function in your base class is marked as virtual, then when you're going to have a list of, say, that base class and you try to run that function, if it's not virtual, It will not try and figure out if there is an alternate version to run. It will just run the base class version. And then finally, we saw if we're wanting to have variables that they can only be seen within that class and its children, we can make them protected. If we don't list anything, then we know that they're now private, which the children then aren't able to see it. But we can make them protected, and then child classes and grandchildren and great-grandchildren and so on can see that information. We can also make them public, but we want to be fairly cautious with where we're using public. So dive in with the stuff with inheritance. It is a very weird area to be diving into. It really is, and it can be really confusing, but super powerful. So experiment with it. And as I said, encourage experimentation with sort of stuff like of the code. See what different things will do. Chuck in debug logs. See why code's running or not running, what order it's happening in. Experiment with it. It's a really great way for learning more about coding. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects. They're freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.